Howdy, Tubalcain again, the old shop teacher. Today will be project number 3 made on the lathe, and it's going to be a V-Pulley, 2-inch diameter. Now granted, you could go down to the hardware store and ask the lady with the mustache how much is a pulley like this, and she'll grab you one off the shelf and it'll be $2.99, and you'd have it and you'd go home and you could use it. But the purpose here is to show you how to do something on the lathe. The final product is not that important. We'll make one that's 2-inch in diameter for a 1/2-inch wide belt, which is a 4L series. And I've already cut the stock. This is 2-inch diameter round, and cut it off of this bar. And you know what? Within this slug of aluminum resides a pulley like this. And all we have to do is liberate it and remove the excess material and find the pulley that is within it. I made this little drawing. Usually I don't bother with a drawing. I dread doing it. But we'll start with, it'll be 2-inch diameter. It's going to be 1.25 inches on the hub, 3/4 inch wide, and the hub is a 1/2 inch wide. The pulley groove is 30 degrees, and the depth of that groove is 1/2 inch. Did I put that on there? I guess it's up here in a note because I didn't have room to put it on, and we're going to ream it 5/8. So the first thing we'll do is take it to the lathe, face it to length, and then we'll drill and ream, and then we're going to mount it on a lathe arbor. And this will be done between centers. I don't think I've done a project between centers yet. Driven by a lathe dog, and we'll turn that, put a groove in there, and then cut our angle, and then put a set screw in it. Now, the sequence of operations on something like this is fairly important, although you can vary a little bit from the way we're going to do it, but I'd recommend to go ahead and follow the procedure that I'm going to show you when you do a project like this. We used to make these in the high school shop, but I had a little casting project, and they would cast one up that was more roughed out to this, and then we just had to do the final machining on it. Let's step over to the Clausing 12-inch lathe. We're at the 12-inch lathe now, and the slug of aluminum is mounted in the 3-jaw chuck. Notice that there isn't any too much sticking out. I like to choke it up short. I'm using the Loris tooling with my favorite facing tool. You may not have that equipment, so just use a regular Armstrong tool post. And we're going to use our cross feed, which on the Clausing lathe is this lever push down. Now we've already got that set, but that won't show up as we start our cut. Okay, we're facing. I did check to see that the tool is on center. Now if you're not quite on center, there'll be a little tit left there, and all you got to do is readjust the height of your tool so you are exactly on center. My RPM is 700. It's aluminum, so we can run the machine fairly fast. I'm going to talk about feeds and speeds in another video. In just a second, this cut will be complete. We'll see if we have completely trued that face. The saw does not always cut perfectly accurate. My carriage is locked, so it cannot get pushed back as we make this cut. Alright, we got a nice cut there. Let's back this off. And it did totally true up. So now what I'll do is take it out, take it over to the lathe, the bench rather, and I will mark it at 1.5 inches so I have a layout line. Then I'm going to put it back in the lathe and face it to that layout line so it's 1.5 inches long. We're facing the second side. Notice that I'm feeding out. Some of you might prefer to feed in. I always like to feed it going out with the automatic cross feed. I do have the carriage locked. safety glasses on. You should have your safety glasses on even as you're watching me. Turn that off, and now we're ready to drill and ream. It's a number 4 center drill, so I always start out by center drilling. That assures that the hole is truly in the middle of the stock. Back that out. Now I've got my other tooling laid out already. I think you ought to do that. So we'll drill all the way through with a 1/4 inch, all the way through with a 1/2 inch, and then this bit is a 39/64. That's one size under 5/8. So we're going to be reaming about a 1/64 of an inch, and there's my taper sleeve for that drill that will fit in the number 3 tailstock. Now I'm drilling 1/4 inch, and I'll go all the way through. If you stop feeding momentarily, it breaks off those long chips. The long chips are just annoying to sweep up or to handle, so I'm using an intermittent feed now to break the chips. As I get in there real deep, sometimes I back it off to clear the chips. Oh, I'm all the way through. Now I'm ready to drill my second hole, which is 1/2 inch. I'll go all the way through with that. When you see 2 shavings coming out of about equal size, you know that both lips are cutting on the drill bit. All the way through. Sometimes I don't know whether I'm showing too much or too little, but for the neophytes, here is how you remove the chuck. You simply back up the tailstock hand wheel, and that will eject the chuck. Now the closing lathe has a slot in there for the tang that drives the tang. This is a number 2 Morse taper. We need to have a number 3, so we're going to use a sleeve, and we will tap it on there like that. Then we will put this in the tailstock till I can feel the tang go in the little slot, and then tap it. And now we're ready to drill. Turn the speed down a little bit. I'm at 360 right now, and this is a chucking reamer, so it's held in the chuck. You may have a one with a taper shank on it, and a ream. Reaming accurately sizes the hole. Drill bit does not drill a hole that is all that accurate in diameter. We'll back this out. Never turn a reamer in reverse. And I'm going to take the work out of the chuck. I like to deburr the hole. I'm using one of these deburring tools. The back side always has much more of a burr on it than the side that you drilled from. Now we're going to mount this on a lathe arbor. If you do not know what a lathe arbor is, it's a hardened piece of steel that's accurately made and ground. This is 5/8 and it says plus on it. The other end just has a minus on it. The plus end is slightly larger than the minus end. Not by much, by 1/2 thousandth or 1/1000th or so, and that will be pressed in using an arbor press till I get it about halfway on there. Now I do not have a arbor press on the premises big enough to drive that in there, so I'm going to take this to another shop and press it into place, and tomorrow we will start machining on it. Okay, through the magic of television, it's the next day. Now I have pressed the aluminum onto the arbor, sometimes called a mandrel, and it was a tight fit, so it didn't go on quite into the middle. That's as far as I could get it on. And I've mounted a lathe dog on there, and I have put the drive plate, or the dog plate, it's not really a face plate, but sometimes we call it a face plate. That's on there. We got the headstock center, and we got the tailstock live center, and we're gonna there's already center holes in the arbor, so we'll go ahead and put that on. And when you do that, lock the tailstock, and you should have a little bit of play here. Don't make your tailstock so tight that this won't wiggle a little bit. Then lock your quill. Now a tailstock dog, or a drive dog rather, can be dangerous. It's easy to catch a sleeve or a file or something else in there, so be careful. Roll up your sleeves, get your safety glasses on. I've changed one dimension here. This is going to be the hub end, which will turn down first. And I changed it so that it's 3/4 of an inch, the same as the other side. And I scribed the lines on like this, and I've got another line on there which I'm going to scribe. It's 1/8 of an inch from the end, and then there's another one here, so that we have 1/2 of an inch left between these two lines. Possibly you can't see that on camera. Now we're ready to start turning. I have a 5/16 square tool in there. Now it's really a turning tool rather than a facing tool, but it's less than 90 degrees included angle. It has a radius on the end, so we won't get a real square shoulder, but that's fine. But I'll take a couple passes and see whether or not that tool is going to serve my purposes. I might have to take it out and put another one in. I'm also going to set my stop right here. Well, I'm going to slide that up and set it so that each time I just machine up to the stop, and that way my shoulder will be the same with each pass. Now if you don't have one of those, you can put a dial indicator on there, or just turn it to your line, but I do prefer this.